Okay, here we go. This is 5.4 for algebra, right? Linear equations in standard form. A lot of this you've seen before. Hopefully it'll come back to you. So take a minute just to do the warm-up on your own. It's always good practice to refresh your memory before we head into this stuff. So write an equation in point-slope form of the line that passes through the given points. If you don't remember point-slope form, look, it's right there. Oh, look at that. Oh, there's supposed to be a 2 and a 1 there, but I didn't teach you that, so let's take that off there. Y minus y1, x minus x1. Okay? Alrighty, give it a try. Okay, this is what you should have gotten. First, you always find the slope, and then you can just pick one of the points, either point, it doesn't matter. When you move it around into y equals mx plus b, it'll give you the same equation of the line. Okay, so what I did was I found -1 for the slope, and then I started with this point right here and plugged it into point slope form. That's what it would look like. If you used this point, it would look like this. Same over here. I got 3 for the slope, and then I picked this point and plugged it in here. This is what it would look like if you chose the first point. This is what it would look like if you chose the second point. Again, if you moved either one of these into y equals mx plus b, you would get exactly the same equation. Okay? All right. Let's this table kind of reviews what chapter 4 we've done so far. So first we started with slope-intercept form. Okay? It's the general form. You use it when you know the slope and the y-intercept, or the y-intercept and one other point. It's useful to model these situations, the fixed fee plus a rate. Okay, like a gym membership. Costs you a certain amount to get in, and then a certain amount beyond that every time you do something. What you can see in this form is the slope and the y-intercept. Okay, the next form we did was point slope, which you just used up here. You use it when you know the slope and 1 point on the line, or 2 points on the line. If you have 2 points, you can always find the slope and then pick 1 point. It's useful to model these situations when you have 2 known pairs or starting point and a rate, like you did in 5.3. All right, what you can see in this form is you can pick out the slope and you can pull out a point on the line. All right, the last form we're going to do here is standard form. So this is what it looks like in general terms. It's ax plus by equals c. Or you might see it like this. But I want you to notice in here that's different than this form and this form is that x and y are on the same side of the equal sign. Okay? A, B, and C are just going to be numbers in your equation, constants. But the most important thing to remember about standard form is that x and y are on the same side of the equal sign. And you can move any equation around to have x and y on the same side of the equal sign. All right, you use it when you know. Well, geez, you can use standard form when you know the slope and the y-intercept, or you can use it when you know the y-intercept and one other point, or the slope in 1 point, or 2 points on the line. All of these instances, you can end up with standard form just by moving them around. Okay? So there's really nothing that goes in this box. It's useful to model combination problems, which we're going to look at. What you can see in this form is not much. You cannot, and this is a common mistake, you cannot see the slope when it's in standard form. Please don't try and pull out the slope when it's in standard form. You've got to put it into y equals mx plus b or point slope form. Okay? All right, let's practice a little bit of standard form. Write 2 equations in standard form that are equivalent to this equation. Well, anytime you can, this is what we started with, you can multiply any equation through by a number and have an equivalent equation. So this one would actually be 2x minus 2y equals 6. You have to multiply it by everything. And that is an equivalent equation. Because ultimately I could divide everything by 2. I could also multiply through by a decimal. Let's say half. and still have an equivalent equation. So if I distribute that 0.5, I'm going to get 0.5x minus 0.5y equals 1.5. And that is an equivalent equation to this. Now, if I wanted to write that in fractions, I certainly could. 0.5 is the same as 1/2 x minus 1/2 y. 1½ is like having 1½ cookies. You have 3 halves. Okay? So these two are the same. I just wrote 1 in decimal and 1 in fraction. So this is one thing you're going to have to do. If it says write two equivalent, just multiply through by number. Write an equation in standard form of the line through this point. So I've got to do standard form. That means x and y on the same side of the equal sign. Okay? So I wrote some steps here. First you find the slope. So let's do step 1. I'm going to subtract my y's, -1 minus a -3, and subtract my x's. This becomes plus plus, so I have -1 plus 3, which is 2, over 1. My slope equals 2. M equals 2, okay? Then pick a point. It doesn't matter which one. I picked this point. Remember, this is x, and this is y. And then you plug it into point slope form. So this would be number 3. Plug into point slope form. Here's point slope. And you just plug in what you know. Y minus this y, which is a -1. So this is going to become plus 1. The slope is 2. X minus 3. And then number 4 I'm not quite in standard form yet, so I have to move the equation around so x and y are on the same side of the equal sign. So I'm going to start number 4. I'm going to put number 4 up here. I'm going to start by distributing this 2. So I have 2x minus 6. My goal is to get x and y on the same side of the equal sign. So I can subtract 2x right now, and it would look like this. I'm going to just do this. Y minus 2x, I still have the plus 1, equals -6. It doesn't matter where you stick that in on this side. I just put it here, which is fine. And I'm going to subtract 1. I have y minus 2x equals -7. Now, my x and y are on the same side. It doesn't matter what comes first. You can leave it like this, or you can consider that this is a positive y. If you want to put the x first, you have to do -2x plus y equals -7. So either one of these would be standard form as long as the x and y are on the same side of the equal sign. Okay. So you're going to have to do these on practice problems. You're going to have to do this on practice problems. Another example of what you're going to see in practice problems is this type of problem. Write the equations of the horizontal and vertical lines that pass through the given point. The given point here was -8, -9. Now, if you just really don't even know how to start this, I would recommend plotting it. Okay? If I go -8 and down 9, it's going to be about right here. -8, -9. Okay. It says write the equations of the horizontal and the vertical lines that pass through this given point. So, the vertical line would be like this, wouldn't it? Okay? Now, hopefully you all remember that the equation of a vertical line is whatever the x-coordinate is, because every single x-coordinate on here is -8. So the equation of the vertical line is x equals negative 8. This is the equation. There's no y in it. It's just whatever the x coordinate is. Okay, now, if I have to write an equation of the horizontal line that goes through that point, the equation here is whatever the y coordinate is, because all the y's on this line are negative 9. If you went over here and down, you would get a y of negative 9. If you went over here and down, you'd get a y of negative 9. So the horizontal equation is just whatever the y coordinate is in that point. Okay? I'm going to write x equals negative 8 here, because all of the x coordinates here are negative 8, no matter where you go. So that's another thing you're going to have to do. Okay? Here is the fourth thing you're going to have to practice. Find the missing coefficient